Hello everyone and welcome to this session. The session is about stoichiometry and problem solving. As you can see, the stoichiometry deals with quantitative relationships in formulas or in interactions. In this case, it's called formula stoichiometry or reaction stoichiometry. But before anything, I want to explain some basics. The definition of mole. You can see the amount of substance that contains Avogadro's number of particles, and as all we know, the Avogadro's number is 6.02 multiplied by 10 to the power of 20. This amount of atom is called 1 mole of atom, and this amount of molecule is called 1 mole as molecule, and similarly in other particles we can see such a thing. And after mole, you can see molar mass or molecular weight, the mass of 1 mole of a substance, usually expressed in grams per mole. For atoms, it's also called atom grams. The data is given always, like C carbon 20 grams per mole, oxygen 16 grams per mole, H hydrogen 1 grams per mole. But about molecules like H2, the water, or ions like NO3 minus, we must calculate the molecular weight. In the water unit, we have two hydrogen. Hydrogen is 1 grams per mole, and we have 1 oxygen, and it means the molecular weight of the water is 18 grams per, or about the ion. We have 1 nitrogen. Its atomic mass for nitrogen is 14 grams per mole, and we have 1 nitrogen plus 3 oxygens, and the molecular weight or molar mass will be 48 and 62 grams per. But totally, in stoichiometry, we have two different kinds, for formula stoichiometry and reaction stoichiometry. There are some differences between two groups, but about formula stoichiometry, as you can see, deal with the quantitative relationships between the elements in one compound. For example, carbon dioxide, we can say in 1 mole of carbon dioxide, we have 1 mole of carbon and 2 moles of oxygen, or 20 grams of carbon and 32 grams of oxygen. The most important things that in some formula stoichiometry, I mean in problem solving, we don't need mole ratio. The most important things in problem solving is mole ratio, and in some cases in formula stoichiometry, but in reaction stoichiometry we always use mole ratio. For example, as we can see in question 1, how many molecules are there in 440 grams of carbon dioxide? I want to say in this question we don't have mole ratio. Why? Because there are no differences between two different sides of the reaction. I mean, how many molecules. The first part refers to molecules, and 440 grams of CO2. Again, CO2, carbon dioxide, is a molecule, because the first part is molecule and the second part also is molecule. We don't need mole ratio. The total format is we look at question mark and molecule is questioned of CO2. This part is question part, and given data is 440 grams of CO. And again we need fraction line. The most important things is that the unit in the bottom of the next fraction must be the same to before data, because we are able to simplify. So this part will be grams of CO2, and in the first step we must write 1 mole of CO2, and we calculate molar mass or molecular weight, C12 plus 2 multiplied 16, 32 plus 12 and 44 grams of CO2, 1 mole of CO2, and again moles of CO2. As I said, we must be able to simplify, and 1 mole of CO2 and another substances is Avogadro's number, 6 multiplied 10 to the power of 23. For solving the problem, we must multiply the numbers that are in the above of the fractions together. 440 multiplied by Avogadro's number, and in the bottom 45, and we can simplify. 440 is 10 times 44, and 10 multiplied by Avogadro is the final answer. The total format of formula stoichiometry, as you can see, question part and given data, and some fraction lines. The number of fractions depends on the question, sometimes 2, 3, 4, 5, and etc., etc. But the most important things is that when we locate question mark for question data and given data, if given data be grams of substance in this part, we must write grams of that substance and 1 mole, and for example gram 1 mole of A, and we continue. This quantity is molar mass or molecular weight. But in the initial part, if we have the numbers of a substance, we must use Avogadro's number and 1 mole of the same substances, and we can continue. And if the given data be mole, we can continue solving the problem. And this point is so important for stoichiometry's mole ratio. There are another example that we need mole ratio for solving the problem. Question 2: how many atoms are there in 440 grams of carbon dioxide? As you can see, the first part we can see how many atoms, and the second part is the CO2 as a molecule. In this case, two different both sides of the question is not the same, then we must use mole ratio. It's so important. As I said, we locate question mark, how many atoms, and question and data, and given data 440 grams of CO2. As you can see, when the initial part is gram, the second part is molar mass, and as we calculate, 44 grams of CO2 is 1 mole of CO2. Again, in this point, we need mole ratio. Here must be mole CO2. 1 mole CO2 has 3 moles of atoms. Why? C1O2, you can 3 moles of atom, 1 mole of carbon, and 2 moles of oxygen, and again mole of atoms and 1 mole of anything is Avogadro's number. And finally, the number that are in the top of the fractions, 440 multiplied by 3 and Avogadro's number, and 44, and we can simplify, and the final answer is 30 multiplied Avogadro number. In this case, using mole ratio was necessary, and this point is so important. But about reaction stoichiometry, we always read mole ratio. We cannot solve the reaction stoichiometry without mole ratio. This point is so important, and the definition is quantitative relationship between particles that are exist in the chemical reactions between reactant and products. For example, n mole of A produced to m mole of B. The quantitative relationship between A and B is questioned in reaction stoichiometry, but the most important things that our chemical equations or chemical reaction must be balanced. For balancing chemical reactions, there is one example Of course, this is a simple equation for balancing. H2 plus O2 yields the water, and I pointed to oxygen because it's the initial part for balancing, and as you can see in the right side we have after locating 2 for the water, because in the left side we had 2 oxygen. As a result, I select 2 coefficient for the water, and after locating 2, the total number of hydrogen in the right side is equal to 4, and in the left side again I give 2, and as a result we have 4 hydrogens in the left side, again 2 multiplied by 2, 4 hydrogen in the right side, and 2 oxygens in the left side, again 2 multiplied by 1 and 2 oxygen, and as a result the equation is balanced, and the question 3 is about reaction stoichiometry. How many grams of water are produced from the reaction of 10 grams of H2 according the following reaction. I forgot the reaction, but the reaction is the same above. 2 H2 plus O2 or 1 O2 yields 2 molecules of water, and as I said before, we must write the question part, how many grams of water is question, and in given data here 10 grams of H2, because the stoichiometry starts with gram, the first fraction must be grams of H2. H is 1, H2 2 grams of H2, molar mass is 1 mole of H2. Again, as I said, we need definitely mole ratio, mole H2, and question data mole H2O. It comes from the balanced equation. For H2 the coefficient is 2, again for the water is 2. It's so important thing, and again moles of H2 and 1 mole of water, H2O, 2 multiplied by 1, 2 plus 16, it means 18 grams of the water is 1 mole, and the final answer 10, 2 and 18, and 2 multiplied by 2. We can simplify in this way, and it means 90 grams of water can produce in this reaction. Finally, I want review some important things. Formula stoichiometry, maybe it doesn't need to mole ratio, but there are some other formula stoichiometry that we need mole ratio and reaction stoichiometry that we must use mole ratio. In the end, I want to appreciate due to your attention